All right, welcome everyone to lecture 7, where we're going to be talking about mass customization through digital design platforms and kit of parts. So here is where we start to see the intersection of advanced design tools, fabrication-aware design tools, and the linkage between these and industrialized construction, whether that's kit of parts, or also we'll even show that this is going beyond just a kit of parts approach. Yeah, just to jump into it, we have our framework for industrialized construction, which we refer back to every week. And today we're going to be mostly focusing on the use of IT or ICT, information communications technologies. But we also will have some discussion about prefabrication and long-term relations. They're related, but the big focus here is on the use of digital design tools. Or digital tools in general. If you remember in our past classes, this was 3 weeks ago, we talked about platforms for industrialized construction. We talked about how not only do these platforms utilize information being transferred downstream, but we also have the possibility for rules and restraints to be transferred upstream. And we can start to embed those into our design guidelines or into a product configurator, which is what we'll talk about today. And we also last class talked about the idea of a platform predefinition. So if you remember, we had these different categories here. So you had traditional design and construction, where we have standards and codes and we engineer everything to order. You can start looking at more prefabricated building systems, which you have a more generic platform and you make some customizations and you have still a lot of freedom. And then we talked about mass customization using kit of parts. It's just where we're going to focus today. And that's the idea of this configuration engineering or configure to order, build to order systems. And then finally, you have non-flexible solutions such as BoKluk, where you have a select variant. You have a single kind of structural module. Maybe you'll make some changes, but the customer does not have the chance to kind of mass customize as much as they are given a single module. And we talked about how as you go from left to right, you have more finished product specifications. So the further along in the design process and the less customization that's available. But in theory, you should have more predictability and performance for these as you go from left to right. Okay, so that's where we started. Double slide. And then now we have, also we've discussed the idea about projects, processes, and platforms, right? So we just covered the idea that there is projects. We're very used to projects in our field. We've talked about projects a lot. And then there are processes, which are a structured way that are continuous. So projects exist for a certain period of time. Processes are continuous. They're used over and over again. And then we talked about how a product platform can be developed, such as a Lego kit of parts. And today we're going to kind of combine process and product platform to talk about the digital platform or the configurator. So let's start by talking about the idea of what is mass customization. I think it's important that we define it. We spoke a little bit about it early in the class. You've heard a lot about it, but I wanted to really define it. So mass customization means that we're producing goods and services to meet individual customers' needs with near mass production efficiency. All right, so it's the idea that customers can receive customized products that have all of the requirements and personalization that they wish for, and you get close to mass production. You're never going to meet the theoretical limit of mass production, because in that situation, you're just producing the same thing over and over again. So of course, you're not going to meet that. You have some switching costs and some changes, but you want to get as close as you can to this limit of mass production, while still providing the right amount of flexibility. But here's a nice kind of drawing where you can kind of think about it from a more customer point of view. So if the customer's here, here's their kind of journey, and down below here is the overall manufacturing portfolio. So these are all the different types of solutions that could be made, and the customer needs some kind of choice navigation tool. We call it, or I call it, a configurator. It's the most common one that's emerging, but it's some kind of choice navigation tool that helps them navigate the solution space. and come up with the design decision that they want. And this solution space helps them translate their design decisions directly into a manufacturing language so that it can then go directly into your manufacturing sequencing. So at some point, you're going to come up with the design decision here, and then you're going to send that design decision to your manufacturing setup, which will then build and deliver that product back to you as the customer after a period of time. And we see configurators all the time. When I moved to Switzerland, I went to IKEA, and I needed a new wardrobe. So I got in the store and I started playing around with this tool. Maybe I could see a show of hands. Has anybody ever used one of IKEA's configuration tools? I'm just curious if anybody has. It was not the most user-friendly experience that I ever had. Anybody out there? I see 1, 2 thumbs up. All right, so you can do it. You can do it at home. All right, I see another one. Great. You can do it at home. You can also do it in the store. I chose to do it in the store. So I had a young child running around while I was trying to make this all work. But basically, you load it up, and here's the wardrobe design, and you start picking out different components and pieces, and you start adding them in. And as you do that, you have certain filters, you have certain dimensions, you can visualize the final product. And it takes a while. Eventually, I get to something like this, right? Probably took me way too long, maybe an hour. So there's a couple of things I'll point out here. Number one is that I have access to immediate costs, right? So I can see exactly the cost implications of my design decisions. I can add or subtract components to meet a target cost that I might have. And in addition, I have immediate visualization. So you can't really tell here, but you have the ability to navigate the space in 3 dimensions. So you can kind of change your viewpoint and really see what the final configuration of the wardrobe is going to look like, right? So these are some of the kind of core tools, design tools for users to engage with mass customization. Now, the functionality can be greater or less depending on the kind of capabilities of the customer. In this case, I did not represent a very sophisticated customer. I was not very good at this. So I needed more help with my design tools. But if I was, for example, more capable, maybe I wouldn't need so much assistance. But we want a way to visualize the product. We want a way to customize the product. We want a way to understand the price implications of the product. So just moving forward. So let me give a quick summary of mass customization. So mass customization is a customer-friendly navigation tool where choices are displayed and selected. They're capable of translating design decisions into the manufacturing language, and it allows a production or assembly of processes that are flexible enough to produce a diverse range of products. So this is the kind of overview of mass customization. If we think about what this looks like, we have several different, here's an easy way from the paper that you were supposed to read and that we wrote about how to think about it in another way. So you have your user input, you have your product structure, which in architecture gets quite complex, which is composed of these kit of parts. That's one part of the product design. And then you have your rules or configuration rules. And we'll talk about those more in a moment. But you have rules that navigate and dictate how the pieces can go together. And these can be within these customized products and these specified parts. Now, these configuration rules might be rules about fit of components. It might be rules about supply chain. They can be whatever kind of configuration rules that you want to embed in the fabrication aware design configurator. And kind of moving forward here, what we see is that there are 3 types of configurators that are existing right now. And there's been a lot of recent development of configurators. So it's been an interesting space to watch over the last few years. The first one is a planning configurator. And the examples I give here are test fit, and I'll give another example of Prism. And these are really geared towards clients, planners, and architects. And there's a need to kind of configure between the site layout, the building profile, and the floor planning. These can or cannot be specific to industrialized construction, although we're seeing quite a few that have kind of a modular approach embedded within them. Then you have this type 2 configurator, which is more for architects and engineers. And that's where you engage with a bit more on the actual specific floor plan design. I thought I had logos here, but I think I left them off. And we have some examples. Our guest lecture today from Splash Modular would be representative of a type 2 configurator, so you can hear more in a moment. And finally, we have a type 3 configurator, which is how you go from these detailed models all the way into the scheduling and the bill of materials. And this is really what's useful for engineers and manufacturers. And I'll give you an example in a moment. So here's the type 1 configurator. This is a company called TestFit, and they're not specifically trying to build this for offsite or industrialized construction, although it can be used with that. But here the idea is that they outline a design space, and then as they adjust certain parameters, they give you a very easy tool that will change the planning of the units. So I think the best way is to just watch this. So here you're lowering the space, and it's moving up and down. And as you do it, you start to see the mix of the units changing, right? So you've automated the rules on, depending on the profile of the space, you change the design and how things go. Then you have another type of planning configurator here. This is the same from TestFit, but this is related to their hospital planning configurator. So you have units you can kind of move and change the space. You can also change different types of units, and you have a different mix as it goes. Yeah, and then, so that's examples from TestFit. I also have an example from Prism. Now, I think you watched the video, but there was another video I wanted to show. And let's see if I can share my screen. All right. Here is, I think you can. So here is, all right, let me pause this. All right, here's an example of, okay, they're trying to do a little rewind here. So here's how they go from Prism to a platform. So Prism is this configuration engine that this is the city of London. You can see, and you can kind of create a new space, and you can go through and generate the kind of mixed design that you want. So you're not drawing this, but you're doing it in minutes. You're generating the overall space. And within that, you can then connect it with a platform or a product platform in some kind of way. And as you do that, you start loading the geometries and the materials, and then you now have a specific kind of spatial representation of the units. And then you can do some other further analyses like shadow analysis or other automated tools. And now this is done with many different softwares, it's possible, but then they also have this way that you can connect it with the offsite construction and the specific kit of parts. And then from there, they export this to a BIM model. And we'll talk more later about the idea that you then export towards this. So here's the way they advertise it. As they say, the buildings can be generated in 1 minute with 100% platform use. You can see the different number of apartments and buildings, and start to get more data and visualization about those metrics. So those are examples of planning configurators, these type 1 configurators at a very high level. Then we have a type 2 design configurator. There we go. Oh, I got to share my screen. All right, here's the design configurator. And I showed this example earlier, I believe, in the class, but it's probably one of the older configurators I've seen. I first saw it in 2015 or 2016 from a company, a startup called Project Frog. And they created their Frog kit. I think we've talked about this before with their kit of parts. And they had their product design done with this software, either SolidWorks or Inventor or Revit. And then they had their project automation here. So from parts libraries, they had an automation engine. And from that, they were able to generate manufacturing and construction documentation. So this is how it works. You have this lightweight browser. You can actually do it right now. If you go to My Project Frog, you can find it. And you can start going through, and you're on a 4-foot, so it's about 1 meter modules. And you start adding in components and parts to customize the space how you'd like. So you're basically filling in. This is a school building. And you add in your kind of structural shear walls, these other things. And then you're able to create the design status check. And from that, you then automatically generate your bill of materials, your component model. So that would be a fully detailed BIM, and all the shop drawings that you need. And in addition, you have all of your automation of your permit and construction documentation. So your structural calculations, architectural drawings, structural drawings. So here we're configuring the design, the actual design of the space. So that's the type 2 design configurator. I mean, and a way you can see is you kind of have a mix of panels, and you're having to select them from the toolbox and place them in the slots as they're needed. And the third typology, which I haven't seen a lot of configurators before for this third typology, but we're starting to see a few more, is what we call the production configurator. And I'm hoping that we can get Mobitz as a guest lecture, still the last guest lecture to be confirmed. They're a Swiss startup that does 3D printing of concrete shapes here. But what they're doing is they're going and taking a specific product that you need and moving into the detailed model all the way into like the permit drawings and the scheduling and the exact bill of materials. So I wanted to pull up the demo because you can go to their page here. So here's the Mobitz configurator. You see here, they call it their product configurator. And so as a customer, it's similar to the IKEA journey, right? So they're going to 3D print whatever you decide, and you have a lot of flexibility with that. So let's say I want to pick a chamber, right? And then I can begin to identify if I want to change things like the length. So let's make it 200, right? And let's make it 125. So we change the height a little bit. I again have that visualization abilities. I have other options here, like I guess I'm adding rebar now to it. So I'm making it more giving it more strength. I don't know how to do all of these things, but I can add tilt or things like this. Okay, so here we add a tilt to it. And in theory, this is all connected to the exact fabrication code that will be run by the 3D printer and can also return immediate costs. So when I go to order here, I tried this earlier. And basically, I'm downloading a JSON file from the order. So yeah, so I don't see a cost return yet, but it's not such a big step to then think that this could also be the cost return. Sorry, I just bounced my mic. Okay, so this is an example of a product configurator for production. Let's go back to the PowerPoint. Yeah, and we saw the short demo here. And so the way we think about this is that we could think about the kit of part configuration framework that's existing, right? So you have experts and end customers that need to give you the user inputs. You have your configuration rules and your kit of parts library, which feeds into your configuration rules. Again, remember, you've kind of defined your product platform. So you've said, here's what we can do. And then you use these rules and inference to develop these customized products. So the kit of parts could be 3D volumetric modules, could be 2 panels, it could be 2D panels, it could be a kit of parts. And then you also have the building regulations, the product composition, production constraints. Those all have to be considered by the configuration framework. And then it's basically a sequential decision-making process where over time, and we won't go too far into the details here, but over time, you are getting, you're configuring step by step as you go through the design space until you get to a satisfying variant at the end selection point. And we also, excuse me, we also have thought a little bit, but we haven't seen very many examples of how you could interlink these three different configuration stages into a more hierarchical kit of part library, such as using a strategy like object-oriented modeling. So here we could think about there's these three layers where we have a supplier element library with a subsystem with specific parts and components. That system library then is assembled in, or is, provided the information for the structural modules, and these structural modules are fed into a graph structure that make up a spatial layout. And this would be the idea that you could then link these different levels of kit of parts library development. But we're getting a little bit into details there. I don't need you to worry about that too much. It's more, this is a kind of higher level way that we're thinking about in our research. And this is the process in which you would need to do, you would need to follow. So you would go and build a graph-based spatial layouts. I don't want to go through all of this, but essentially what it comes down to is that you have a sequential decision-making process that's linked between these different stages. All right, and then finally, we can start to think about ontology modeling. Again, this is more advanced than you need for your project, but maybe you're interested in it. We can start to think about the hierarchy of the modules. So we can start thinking about the module aggregation. And then we can model the configuration rules using semantic web rule language, which can help us with our configuration. So we can have different types of constraints that we model the configuration, like composition, cardinality, or dependency, right? And so just a short example of composition, you can say that this module has an entrance of exactly one entrance, or has sleeping of exactly one sleeping, or you could say at least two sleeping arrangements. So you can start to define the composition and then use this to guide your configuration rules. Yeah, here's some examples of the other types of constraints. And these are all a part of the paper that you read. So if you're interested, we can certainly discuss more moving forward. Sorry for the low resolution, but here we have a conceptual view of how platforms change the design process. So traditionally, you have a limit of configurability. So you have a small percentage of common parts, and then you have a lot of unique parts. And you can only configure where where this gap is between your common parts and your unique parts. And the idea is that by introducing a product platform and engaging in this mass customization with modular design, you start to create this space where you have a lot of variant modules that do have some unique parts here, but they also have a lot of different variations, and then also some common parts and modules that exist in all of the modules. So if we think about this at a high level, configurators change the design process in 6 ways. So we say that when you use a configurator, projects are configured and are no longer unique designs. And this leads to what we call a fabrication-aware design process. Because configurators have the constraints linked with them in some way, and they also enable the user to understand these constraints because the user is constrained, then the design process becomes fabrication-aware. And then there's a need for digital systems integration. So we need to somehow think about the entire system and how is it integrated digitally? How do you integrate this with, for example, your supply chain? Then it also shows the need for increased customer focus, because you need to actually understand what choices does the customer want. Mass customization falls apart if you give the customer too many choices. So you need to then refine the decision space, so you really understand what are the choices the customer wants to make. And then I'll speak about these two more in a bit more detail next, where one shift we see is this move towards BIM as output instead of BIM as input. So building information modeling as the output and not the input into the process. And also this opportunity to engage in Industry 4.0. So I'm going to say more about both of those on my next slides. Before that, I just want to take a brief pause and see if there are any questions on this so far. right. If you do have questions, I think we'll have a bit of time at the end today, so or after my lecture, so we can discuss some questions. All right, so first, the last 2 points here. One is that I think that we're moving with configurators or other design tools from a process where we no longer have BIM as the input into the process, but BIM as the output. And what I mean by that is, this is my very loose drawing of a BIM process, a BIM-based design process as it exists today. If you start with a project, you start with kind of we say blue sky or a blank canvas where there's nothing done. And what happens is that the designers and the engineers start adding things to this. They start adding, usually if it's a BIM project, they'll create a Revit file or ArchiCAD, and they'll just start adding the design over time. And then you need to kind of coordinate this with the other project constraints. And then eventually you're going to have to create your permit and construction drawings. You have some information loss when you have model exchanges with common model exchange formats like IFC. And eventually you're going to get to the fabrication stage. Now, remember, you haven't really coordinated with the supply chain or the fabricators. So you'll give the fabricators the concept, and then the fabricators will come back and tell you, well, actually, it's cheaper if you do it this way, or we can't do it that way. We don't have the capability. So now you have to change your design in this way. And that's this arrow here. So now you have this coordination feedback loop. So you redesign until finally you settle on a final design. And that's typically how we follow the process. So it starts with BIM, and we work towards adding more detail into the model. I would compare that to where I think we're going in the near future, is the idea that BIM is the output and that code is really the input. We saw for example, from both Mobbit and also from Project Frog, and I think we'll see from our guest lecture with Splash Modular as well, the idea that we have more of a lightweight, it could be a cloud-based, browser-based design platform or configurator, where we embed the manufacturing and assembly constraints, but we're not working in such a heavy file situation such as you have with Revit or other kind of BIM tools. You might link to those, you might even do some of the design using an API, but the main work is happening with this more lightweight setup. And then from there you have, as an output, you have the manufacturing information, so the bill of materials or the CNC or other digital fabrication, G-code or whatever it is that you're using. You have also the assembly, and you automate then the permit and the construction drawings, the structural, architectural calculations, and maybe the BIM will be exported. So here we have the BIM being the output of the design configuration, which can be used for other features and not as the input or the starting point. We also have the connection to Industry 4.0, and I don't know how much you know about Industry 4.0. It's a bit of a buzzword. It's often thrown around. I'll just take a moment to introduce it, but the idea is that the first industrial revolution was mechanization. The second was mass production. And the third was computer and automation. And the fourth now, which we say we're working on, is this idea of cyber physical systems, or interconnected, robots, cloud computing, kind of bringing everything together. And if we think about how this plays out in construction, the idea of Industry 4.0 is that in the past, you had to really kind of consolidate everything within one factory. But one of the key driving ideas in Industry 4.0 is the idea of smart interconnected factories and more resilient supply chains. So some examples here is that you can have a product developer that's capital light, and they work on the digital systems integration, but they themselves are not purchasing all of the equipment for their own purposes, but they're instead just integrating on the supply chain. And this product developer engages deeply and iteratively with the clients to understand the use cases. And then from there, they modularize the product architecture, so they outsource the actual construction of the modules. And Project Frog is a good example here, where they developed that configurator we saw called My Project Frog, but they actually don't own any manufacturing equipment themselves. Instead, they just outsource and make the connections. And then they use and build digital product models throughout the life cycle. Finally, they co-create the module design with the supply chain partners. So they work together to create a final design. And this finally leads to the idea that maybe we're seeing the future of construction in this way. So we start with the idea we have intelligent, we want a new asset. We do some kind of design and development, which engages in mass customization. And we move to this manufacturing stage of Industry 4.0 and optimized supply chains. And there's optimized configuration rules that feed back into that design development, right? So we're having mass customization, configuration rules moving back. Then we go into the assembly stage, and we have, we use BIM as an assembly guide. And eventually we have these intelligent assets, which have smart interconnected sensors that can tell us about their current status, their maintenance, their need to be upgraded. And we can then engage with things like circular economy for, then reuse, redistribution, remanufacturing, and recycling. So this is kind of one feedback loop that I've seen proposed that I really like, which I think could be a way that we see the future of the built environment go.